Okay, so now we're going to talk about solving quadratic equations by graphing. This is one of the easiest ways to solve quadratic equations. So our I can statement here is I can use a graph to solve and determine the number of solutions of a quadratic equation in one variable. So when we're solving a quadratic equation, remember when we're factoring, we would get two different solutions. And it's because we're looking at where does our parabola cross the x-axis? And most of the time it crosses the x-axis in two different places. So that's why we get two different answers, is because there's two different places that we hit the x-axis. So that's what we're doing here. We're going to use these graphs to find those x-intercepts. I have Desmos open on the side for later in the lesson. So right now we're going to look at the graph of f of x equals negative x squared plus 2x plus 3 here that's shown. We want to find the zeros of f of x. So remember, zeros, x-intercepts, roots, solutions, all mean the same thing. So on this graph here, the x-intercepts, or the zeros, I have those dots on there, okay, are right there. The one on the left, that's the point -1, 0. And the one on the right is 3, 0. So if I'm finding the zeros of f of x, okay, I would say that the zeros, or the solutions, are x equals -1, because that's the one on the left, and x equals 3. So those are the solutions to this equation. And that's it. So we don't have to factor, we can just look at the graph to help us find those solutions. So down below it says the x-intercepts are also called solutions, roots, or zeros of a function. We've seen that before. When we graph a quadratic equation, we can see how many x-intercepts there are and what they are. So quadratic equations can have 2, 1, or 0 real solutions. If the equation has 0 real solutions, then it has imaginary solutions, which we'll learn about later in this year. Okay, so for the following examples, we are going to first write the equation in standard form. If you don't remember standard form, it's ax squared plus bx plus c equals 0. So we want it to look like that before we find our solutions. Then we're going to use the graphing calculator to graph them and state how many solutions there are and what they are. Okay, that's why I have Desmos open on the side there. So the first one, x squared plus 7x equals -10, that is not in standard form. But I can make it into standard form by moving that -10 to the other side. So I'm going to add 10 to both sides here. I always make that line really long there, but we end up with x squared plus 7x plus 10 equals 0. So to put it into standard form, we want to make it equal 0. Now remember, we can only combine like terms, and that 10 is not a like term with x squared or 7x, so we just have to write it at the end. So under number 1, for standard form, I would put x squared plus 7x plus 10 equals 0. And over here on Desmos, I actually have it graphed already, but if you are on your Chromebook, go ahead and pull up Desmos and graph that equation. And if you touch the graph or click on the graph, you'll see that it pulls up the important points there in gray, those gray dots. But with this parabola, we can see that it has two different x-intercepts. It crosses that x-axis twice. So under number of solutions, I'm going to write 2. Now what are they? I can click on those gray dots on Desmos and it tells me what those points are. So my two solutions are x equals -5 and x equals -2. Okay. And that's it. Let's move on to number 2. Number 2, we have x squared plus 2x equals 3. Make it into standard form by subtracting 3 from both sides. So x squared plus 2x minus 3 equals 0. That's our standard form. I have that one pulled up next here on Desmos. X squared plus 2x minus 3. You don't have to type in equals 0 on Desmos. You only need to type in the equation on the left hand, or on the opposite side of 0. Okay. So x squared plus 2x minus 3, that's that parabola that's graphed here. We can see again, it has 2 different x-intercepts, so there's 2 solutions. We touch those gray dots or click on those gray dots, and our solutions are x equals -3 and x equals 1. Okay. Moving down to number 3, x squared minus 8x equals -16. Add 16 to both sides. So we get our standard form is x squared minus 8x plus 16 equals 0. On Desmos, if we graph that one, so this bolded line that's horizontal here, that's our x-axis. This green parabola barely touches that x-axis. We can see it doesn't go through it and then back up again, like a lot of the parabolas we've already seen. This one just barely touches that x-axis, and you can see it only has one gray dot here. So this one only has one solution, and that solution is 4. So what's going on? What's different about this one? So if you remember back in the introduction video, one of the examples we looked at, we saw that we got the same answer twice. So remember, with factoring, we get 2 different solutions, or I guess we get 2 solutions, and in that example, we got the same number twice. This is an example of what that kind of graph would look like. So if we were to try and factor this equation and solve it, we would get the same solution twice. And the graph, it looks like it just hits that x-axis once. So it's just that one number 2 different times. But we don't write it down 2 different times, we just write it down once. Okay. Let's look at number 4. We have negative x squared equals 2x plus 4. Now a good rule of thumb, a good thing to always make sure you do is try and keep that x squared positive. So on this one, instead of moving 2x and 4 to the left, I'm going to add x squared to both sides so that it becomes a positive number instead of staying negative. And because it's x squared, I'm going to write it out front because that's where x squared belongs. Now on this one, we have 0 equals x squared plus 2x plus 4. That's the same thing as x squared plus 2x plus 4 equals 0. Those two things are the exact same. So with standard form, I could write x squared plus 2x plus 4 equals 0. I have run out of room. I apologize. Let me fix this up a little bit. Maybe if it will ever erase. I'm just going to clean it up. The work is still good. I'm just going to move it over. There we go. So I moved the x squared over to the right instead of everything else over to the left. So over here on Desmos, we can see that our x-axis there is the bolded line with 0 on it, and the parabola does not ever touch that x-axis. It's way above it. Okay. So how many solutions does this one have? This one has 0 solutions. So what are they? There are no real solutions. These solutions are actually going to end up being imaginary. Imaginary solutions. And we'll learn more about those later. Okay. So what does this one look like if we've seen something like this before? If we think back to factoring, we should always get two solutions. It might be the same number twice, but we'll always get two solutions. This equation, we would not be able to factor. So we couldn't factor with one of the methods we've learned so far already. Okay, so that's why we get 0 solutions on this one, is because we cannot factor this. Okay, let's look at number 5. So we have x squared plus 36 equals 12x. I'm going to move that 12x over by subtracting it from both sides. And to put this into standard form, I'm going to sandwich it in between that x squared and 36. Because that x, that's where x belongs, is in the middle. So my standard form is actually x squared minus 12x plus 36 equals 0. Over here on Desmos, this is another one where the parabola just touches the x-axis once, and the point that it touches the x-axis is 6, 0. So this has one solution, and it is x equals 6. See if you can try the next one on your own. Hint, it's already in standard form. So go ahead and find those solutions. And if you finish, go ahead and come back and we'll check our answers. This one's in standard form already. It's already equal to 0. So over here on Desmos, graphing this one, it has 2 solutions. We can see it has 2 x-intercepts. If I click on the graph here, it will tell me those solutions are x equals -4 and x equals 0. Okay. Moving along here, number 7, we have 2x plus 5 equals -x squared. This is another one where we want to make that x squared positive. So I'm going to add x squared to both sides. X squared belongs out front, so I'm going to put it in front of 2x and 5 so that my standard form is x squared plus 2x plus 5 equals 0. On Desmos, I had to zoom out a little bit because it jumped up above the x-axis. It doesn't touch the x-axis at all, so there are 0 solutions. There are no solutions because they are actually imaginary. So this is another one we would not be able to factor. So we don't see their solutions on the graph. Okay. Number 8, x squared plus 7x equals -6. Add 6 to both sides. So our standard form, x squared plus 7x plus 6 equals 0. On Desmos, that's this one right here. Ooh, let me zoom out. This one's a little bit below the x-axis is where that vertex is. So if I click on that, I can see there's 2 x-intercepts, which tells me there are 2 solutions. Those gray dots tell me those 2 solutions are x equals -6 and x equals -1. Number 9, we have x squared equals 3x minus 3. So on this one, it would be really easy to move x squared over to the right side of this equation, which you could do. You would still get the same answers that we would get otherwise. But remember, it's always a good idea to try and keep that x squared positive. So instead of moving x squared to the right, I'm going to move 3x and negative 3 to the left. So I'm going to first subtract 3x from both sides. So I end up with x squared minus 3x equals negative 3. And then I'm going to add 3 to both sides. So I end up with standard form is x squared minus 3x plus 3 equals 0. And that way I kept x squared positive instead of making it a negative x squared. Go ahead and graph this one. This is another one that does not touch the x-axis. These solutions are imaginary. Okay. Last one of these examples. We have x squared plus 10x equals negative 25. Add 25 to both sides. We end up with x squared plus 10x plus 25 equals 0. And if I graph that on my Desmos over here, you can see that parabola barely touches that x-axis in one spot. There's one solution, x equals negative 5. Okay. Last but not least, this word problem. So number 11, it says to keep water off a road, the surface of the road is shaped like a parabola. That way the water runs off the sides and you don't have a bunch of puddles in the middle of the road. A cross-section of the road is shown in the diagram. A cross-section just means you're looking at it like if you cut it and you brought it up to eye level, that's what you're looking at. The surface of the road can be modeled by the equation y equals negative 0.0017x squared plus 0.041x, where x and y are measured in feet. Find the width of the road to the nearest tenth of a foot. Okay, important stuff. Always figure out what's the important information they've given me and how do they want me to use it? What are they asking me to do? So important, that equation is very important. Okay. I'm dealing with a parabola, which is good because that's what we've been looking at this whole time. And then what is it asking me to do? It's asking me to find the width of the road. Okay, so it's asking me to find from one side of the parabola to the other side of the parabola. Now this diagram isn't the best picture, but that red curve that you see at the very bottom there, that's the parabola we're looking at. It wants me to go from one corner to the other corner of that red curve. Okay. I'm going to use Desmos to help me figure out what those 2 points are, just like we've been doing this whole time. Okay, because if I'm trying to find the width of this, I want to find out how far am I going from one point to the other. So how long is it from this side to this side and what those 2 points are. So over here on Desmos, I actually have it already typed in there. This is a really flat curve. It's kind of hard to even tell that it is curved at all. But if I click on that red curve, you can see, I have to zoom out a little bit more here. You can see there are 3 gray dots. The one in the middle is actually the vertex. It's not on the x-axis at all. These other 2 are. So those are the edges of this road. The left side is at 0, 0, and the right side is at 24.10. So how far is it to go from 0 to 24.1? Well, to find that distance, you would take the bigger number, subtract the smaller number, and that tells you how far apart they are. So 24.1 minus 0 is 24.1 feet. So the distance between those 2 points, the edges of the road there, is 24.1 feet. And that's it. So graphing parabolas is a really easy way to find solutions to quadratic equations. But if we can't always graph them, we're going to learn other ways to be able to do it as well. We already know how to factor. That's another way to find solutions. So hopefully now we are comfortable with looking at those graphs. We can use some other methods to find these